is D-Day.
D-Day. It relied on courage and ingenuity. As much as the success of the landing was down to the bravery of soldiers, it was made possible by inventions and new machines. But to me, one engineering marvel stands out from the rest.
What happened here on this beach in the hours and days after landing made the whole invasion possible.
Planning started in 1943 for D-Day, a massive invasion of France. The Allies landed on 5 different beaches along an 80-kilometre stretch of the Normandy coastline: Utah, Omaha, Gold, Sword and Juno. If it was to be successful, the operation, codenamed Overlord, would depend on the speed with which reinforcements and supplies could reach Normandy. Initially, this was going to be done by landing craft, but the Royal Navy worried that repeated landings would damage the bottoms of craft. The process would also be too time-consuming because it relied on tides. To supply the tens of thousands of soldiers landing and fighting their way inland, the Allies knew they would need a port.
Well, once you've done the initial attack, without the supplies coming in and the men and the material, you can't go any further, so you can't develop your bridgehead and you can't launch your campaign.
So if you land troops on the beach, the risk is that while your landing craft, your ship has beached, the tide goes out, leaves the craft stranded, and then you might have hours and hours until it can be refloated, and that's time that could be spent heading back to the UK to get more troops, more supplies, more vehicles.
Thousands of tons was needed to support the Battle of Normandy: ammunition, reinforcements, medical supplies, fuel. Each man would need 40 kilograms of supplies per day. And after a failed raid in 1942 on Dieppe, it was obvious that the German defences were too good for an existing port to be captured. So they would have to bring one with them.
They would have to build it in the UK, ship it along the English Channel as troops were landing in Normandy, and then construct it here, put it back together on these beaches so that they could have supplies coming, the first supplies coming through here on D-Day +1. No easy task. So what that meant was they'd have to build a floating bridge that would go a mile out to sea to where it was deep enough that big ships could come alongside, even at low tide. They had to build breaks, big cement breaks to stop any storm damage, that sort of thing, and also protect it from U-boats and the like. So, no easy task to build that, to protect ships and to allow supplies to come along constantly for the Battle of Normandy.
To make the invasion possible, new technologies and engineering marvels were designed and produced. Tanks that could float, mine clearance vehicles, tracked bridges, an underwater fuel pipeline.
But one of the biggest challenges was making concrete float.
Prime Minister Winston Churchill took a personal interest in the project and made clear that he would accept no delay. He sent a memo in 1942 that was to become famous. Piers for use on beaches. They must float up and down with the tide. Don't argue the matter. The difficulties will argue for themselves. The harbour project was given the codename Mulberry. They were to be constructed off Normandy in just 2 weeks and to have the capacity of the port of Dover.
It took the entire UK construction industry effort to manufacture it. The main component was a thing called a Phoenix caisson, which is effectively a floating concrete tank, and these weighed anywhere between 2,000 and 6,000 tonnes. And to build them all took 250,000 tonnes of concrete and 31,000 tonnes of steel. And so to build them, they had to build them all around the UK. And once the ports and harbours were full, they then had to excavate riverbanks and build them in dry docks there. And once they'd made them, they then had to take them out and sink them so they couldn't float off. But it also meant the Germans couldn't see what they were doing.
If you talk to the people who are actually building them, because of the secrecy of D-Day, they didn't know what they were doing, and all they knew is that day after day they were pouring more and more concrete and building this reinforced concrete structure, and no one knew what it actually was that they were building.
On Normandy Beach, the tidal range is around 6 metres. This is how much the tide moves in just 15 minutes. So the harbour definitely needed to float. To make a floating harbour that ships could come alongside, could carry the weight of tanks and ammunition, the Allies would need concrete, and lots of it. And remember, to get the harbour from Britain to Normandy, it had to float. In total, 275,000 cubic metres of concrete were floated across the channel, a total weight of nearly 600,000 tonnes, and as well as that, 31,000 tonnes of steel. The construction effort in the UK took 45,000 men 8 months to complete. But how did they make concrete float?
It's all to do with the amount of water you displace. So if you have something that weighs 2,000 tonnes, you can displace 2,000 tonnes of water, or more than 2,000 tonnes of water, it will float. So you can make anything float essentially. It needs to be hollow, you need to contain air, because if you have something that's very dense, of course it's going to sink. So you've got to contain pockets of air. So these were big tanks with compartments in, and in each of the compartments they had pumps, so they could raise and lower them onto the seabed. When the Allies had been doing a reconnaissance of the beaches since about 1943, so they'd mapped out, Royal Engineer divers had mapped out the whole of the coastline and knew exactly what the coastline was like.
When each of the secret parts finally made it across the English Channel, they were assembled to this plan. Bombardons, the first type of breakwater, was a chain of floating steel rafts. Rhinos were power-driven pontoons on which cargo was brought ashore from ships too big for the inner harbour. Phoenix units. These were floating concrete breakwaters or caissons that were sunk to create a protective wall for the inner harbour. Leviathan. This was a ship that would fill the concrete with water and sand to sink them. Corn cobs. These were old ships that were scuttled to add more protection to the harbour. The breakwater was codenamed Gooseberry. Liberty Trot. This was a line of buoys for Liberty ships to safely come alongside. Next, beetles, floating pontoons, and on top of them, whales, bridges all linked together to form a roadway. At the end of these were spud piers, where equipment and supplies were unloaded onto trucks. Ducks were of course the Duck W amphibious vehicles, and duck cushions were their assembly points. Finally, there was the planter, the codename for the officer in charge of the sinking arrangements for the concrete caissons. And the headquarters was where you would find the naval officer in charge. So this is what Mulberry B looked like.
At Arromanche, off the beach of gold, 'neath the rocket's deadly glare, we towed our block ships into place, and we built a harbour there. Mid shot and shell we built it well, as history does agree, while brave men died in the swirling tide on the shores of Normandy.
By the 6th of June, everything was ready, and the harbours were floated across the channel by a team of 132 tugs. Both harbours were operating from a week after D-Day, and when at maximum capacity, a truck or vehicle was being unloaded every minute and 16 seconds.
D-Day took place on the 6th of June, and on the afternoon of the 6th of June, 170 tugs pulled 1.5 million tonnes of harbour across. The first caisson was sunk on June the 9th, and by the 18th they had 2 harbours up and running and open and taking supplies and materials. So it was quite a quick operation. The pier heads went up and down on cables, so they were placed on the seabed, and as the tide went up and down, the pier heads went up and down, so they could use it in all conditions. The road, there was 16 kilometres of steel roadway that twisted to cope with the action of the waves. So it was really very, very sophisticated and pushed technology to its limits.
Mulberry A was constructed off Omaha Beach to supply US forces. Mulberry B, nicknamed Port Winston, was built at Gold Beach and Arromanche to supply British and Canadian troops. But Mulberry A was destroyed in a storm on the 19th of June, and in the days following, some ammunition supplies in Normandy ran low.
It hit the beaches that were supplying our army and wrecked everything in its path. 2 years of careful planning and hard labor. 2 years of skill and sweat.
It's true that the Americans managed to do without their Mulberry Harbour in the end, But I mean, some of that was through quite desperate measures, like I think they even cut holes in the side of ships sometimes to unload them and then welded them back up.
Port Winston remained fully operational for 6 months after the landings.
In June 1944, this beach had become the busiest port in the world.
The first 2 weeks after D-Day, British beaches allowed the unloading of more than 120,000 tonnes, 50,000 vehicles and 285,000 men, all within the shelter of gooseberries. After the 20th of June, the harbour itself, Mulberry B, was unloading 6,750 tonnes a day. In total, it was used to land over 2.5 million troops, 500,000 vehicles, and 4 million tonnes of supplies. The use of Mulberry B began to decrease only when the Allies captured the port of Antwerp. But some of the technologies that made it possible are still used today.
Well, we still use the equipment bridging. The modern army uses equipment bridging, which is a much smaller version of it. They've used floating pontoons for bridging, so a lot of the developments have carried on. In Iraq, in the first Gulf War, they built a floating pontoon to offload ships taken up from trade, so the ro-ro ferries. So that again is a very similar principle, and that went up and down with the tide.
But as well as the harbours, what's inside this tent was equally as important.
So the Mulberry Harbour is just one piece of the puzzle of the plan of D-Day, and there was other ways that supplies could come ashore. One of them was the landing craft, and this LCT Mark III is being conserved and restored by the National Museum of the Royal Navy, and these played a massive part on D-Day.
These are a pillar of bringing supplies and the logistics effort long after D-Day itself. And what you find is it's all about increasing levels of capacity. So you put in the Mulberry Harbour, and then you can use different types of ships. You can use conventional merchant ships, which require their cargoes to be craned out of their hold and put ashore. And that's great, that increases your shipping capacity. But once the Mulberry is there, they don't stop using these, because the army ashore is getting bigger and bigger and bigger, and its appetite is absolutely voracious. So all the while you've got things coming in through the Mulberry, you've also got hundreds of these craft and bigger ones running relentlessly backwards and forwards and dropping stuff on the beaches. It's all in use all the time, and the whole thing doesn't work properly without all of it.
When you think of D-Day landing craft, you usually think of those small ships that were filled with soldiers landing on the beaches and then running into battle. But this one, you can tell, is a lot bigger, and this could carry up to 10 tanks or truckloads of supplies, and it could land almost anything onto the beaches of Normandy to resupply those soldiers fighting.
See, for me, the most impressive bit is the whole, it's the big picture. I think it's really dangerous when we go down those rabbit holes and say this one thing made D-Day work. It doesn't work like that. The way D-Day works is it's this huge interlocking puzzle of individually tailored solutions to a huge number of problems. It's looking at every single potential threat and neutralising it before you've even started the operation. That's the miracle for me.
I don't think there was a point in the campaign when the Allies sort of said we've got so many troops, so many supplies, we can just slack off a bit now. It was the Allied armies constantly needed huge quantities of fuel, of ammunition, and then all the other things like food. So every single possible way of increasing the quantity that was flowing over there was so important.
They couldn't have done it without engineering. I mean, the whole thing was a combination of both military engineers who were serving, but also the construction engineers who were supporting them, were all flat out constructing this stuff. And of course, a lot of the civil engineers had joined up and were in the Royal Engineers. And so it's really a combined effort. And without military engineering, you're not going to succeed anywhere.
Without the engineering marvel of the Mulberry Harbour, who knows what the outcome of the Battle of Normandy and Europe would have been. But no one doubts its contribution, and what's left of it on Normandy Beach is a reminder that the sacrifice of soldiers on and after D-Day might have been for nothing if it wasn't for technology, engineering, and ingenuity. Thanks for watching this episode of Intel. If this is your first time finding the series, then there's plenty more episodes like this one, And if you want more content on D-Day, we've got tons of stuff on our website, including an article that goes a bit more in depth into the Mulberry Harbours, and the link to that one is in the description.